Great job. Way to get that homework finished and get it in. You are doing very good with that. So let's go ahead and go over a few questions, a few things that we've been using this whole chapter long that we're going to just keep on using and keep on using. We need to make sure that we have. So we've been talking about different kinds of coefficients that we have. And what is a literal coefficient, Anne Grace? What's the literal coefficient?
It's the number.
It is, can you help her out, Jenna?
Literal coefficient is like the variables, like the x and the y.
The x and the y. You're thinking of, Anna Grace, do you know what you're thinking of?
Is it the constant?
Okay, it is the constant, but when we're talking about coefficients, it is called the numerical coefficient. So you were close. So give me an example, Anna Grace, of a literal coefficient. Give me, just throw one out there.
Z.
That's right, z. Okay, Maya, what kind of terms can be joined together when we're adding or subtracting? That's right, like terms. So Anna Grace, can we add d and y?
No.
We can't, why not?
Because they're not like.
Because they're not the same, very good. But we can add 3 and 5, right?
Yes.
Right. Why can we add 3 and 5, Jenna?
They're like?
Because they're just numbers, so we can add numbers, but whenever we have variables and we want to add them, they have to have like terms. So give me an example of some like terms, Anna Grace.
So, like x squared and x to the fourth power?
Yes, those are like terms because they have the same base. So we could have xy and xy, or xy and xy like terms, Jenna?
No.
They are not like terms?
Wait, what did you say again?
So if I have xy and xy, are those like terms?
Yes, I misheard you.
That's okay. Kelly, is x squared and xy, are those like terms?
No.
They're not, but I have an x and a y, so I don't understand. Why not? Can you tell me why?
Because the powers are different on the x's.
The powers are different. So these are rules that we want to be keeping in mind as we go throughout like terms, and that even means having the same, which I think I just told Anna Grace wrong when she said, what was it you said, Anna Grace? Do you remember?
The example again?
Yeah, what example did you give?
I think I said
Did you say x squared?
X squared and x to the seventh power.
Yes, so those are not like terms because they don't have the same exponents. So that is my bad. So make sure you have that straight. Our exponents do count. So Anna Grace threw me for a loop there. Good job. You get points for that today for throwing your teacher off. Very good. All right. How many of you guys like to play different sports at PE? Maybe dodgeball. I'm not talking about basketball or volleyball, but sports that we don't really have a team for, but we like to play them at recess or at PE, which you all have. We have dodgeball. I remember when I was at camp, we played 9 square in the air. I don't know if you guys ever played that, but I sure like it. And there are certain rules that are rules, they're rules, and they're never going to change. It's always the same. Maybe in dodgeball, I'm pretty sure it's a universal rule that if you throw the ball, and if I throw the ball at Anna Grace and she catches it, well, I'm out. I think everybody in America across the world plays dodgeball that way. I could be wrong, but I'm pretty sure that is a hard and fast rule. But we have some rules with our exponents that are hard and fast. They do not change. And you guys are very fortunate today because if you guys know how to count, if you know how to add, then you guys, this is your lesson. You will love this and we will jump right on and you'll be able to just plug right through these problems. So go ahead and look at this first problem that I have up here. And I have 7 cubed times 7 to the 6. And this comes back to the question that Anna Grace and I just talked about. Anna Grace, can I add those if I wanted to?
Yes.
I think you read my problem off the board, didn't you? When you gave me like terms?
Yes.
You did. Anyways, so we are not talking about adding these. We're going to talk about multiplying these. But now I see what Anna Grace did. She's pretty nifty there. So this could be written when we talked about powers. We could write this a different way. If we have 7 cubed times 7 to the 6. We know that 7 cubed means 7 times 7 times 7. Does everybody agree with me that that's what 7 cubed means? So we could write 7 times 7 times 7. And then we have 6 sevens. So we're going to go ahead and write our 6 sevens. So So we're gonna put our multiplication symbol and help me, well, I need to make sure I get 6, make sure I don't miss any. So we have 1, 2, 3, 4, 5, 6. Did I get that right? We have 3, 1, 2, 3, 4, 5, 6. Okay, now we have all of these and we can multiply them. And we're gonna do that by just putting these all together. We're gonna count how many we have, and that is gonna be our exponent. So anytime we are multiplying exponents that have the same base, we're going to add the exponents. So we know that these have the same base. We put them all out and we have a bunch of 7s. So let's count them. Count them with me, class. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I must have gotten it right because 3 plus 6 equals 9. So we know that we could write this as 7 to the 9th power. And that's a lot easier to do than writing out all of our 7s. But could we write out, what if we had something like this, because this is where our rule comes in, we have to have like bases. If the bases aren't the same, you can't do anything with it. So if we had had 7 to the 3rd times 6 to the 6th, we wouldn't have been able to do anything with that because they're not the same. We could write out 7 times 7 times 7 times 6 times 6 times 6 times 6 times 6 times 6, but there's really nothing to do about that besides multiply it. Does anybody know off the top of their head 7 to the 9th power? I have it up here. Actually, I don't. 7 to the 9th power, does anybody know what that would be? 63. I think it's a little bit bigger than that. Maybe we'll come back to that at the end of class. 7 to the 9th power is a very large number. Okay, so remember we said if we want to add our exponents when multiplying bases, Jenna, what has to be true?
Bases have to be the
The
same.
bases have to be the same. So let's look at this expression that we have up here. So we have x and an x and a y. So since the expressions have to be the same, the bases have to be the same in order to add them. So I want to write this out in long form so we can see what we're doing. So we have x times x times x times x. Does everybody agree that that represents this x to the 4th? Okay, now I'm going to go ahead and put another x up here for this one. So we've taken care of that, we've taken care of that. And now we have to write out our y 3 times because it's being cubed. So y times y times y. Now we can just add up all of our variables that we have that are the same. Now we can just put them together and that be our exponent. So we have 1, 2, 3, 4, 5. So that will be x to the 5th power, y to the 3rd power. And you can see that I would have gotten that easily if I had just said, oh, I have another x. And we understand this power. What is x's power understood to be, Anne Grace?
1.
1. Then we know that 4 plus 1 equals 5, and that would have given us x to the 5th, y cubed. You guys can go ahead and turn your attention over here to this board. We have some that are very similar, and we're just going to practice doing the same thing. I don't think we need to write it out the long way. I think you guys understand that. So one last time, let me ask this question, make sure we have it. What has to be true if we're going to add our exponents, Kelly?
The bases have to be different.
The bases have to be different. Anna Grace, do you agree with that?
I do not.
You do not agree. I see most of the class, they're not quite agreeing. Anna Grace, why don't you agree with that? What did I say has to be true in order for us to add our exponents?
You said the bases have to be the same.
They have to be the same. That's right. And that's what our books say also. So up here we have 3 squared times 3 to the 4th power. By a nod or a shake of your head, would everyone agree that these bases are the same? I see most people nodding their head. Kelly, you can participate. So we have the same basis. So now we know that we can just add our exponents. So that's easy. Like I said, if you know how to add, this lesson is for you. So we're going to just go ahead and keep 3 because we're multiplying. And what is 2 plus 4, class?
7.
It is 6. Make sure you're paying attention. So that will be 3 to the 6th power. cubed times x squared times x to the 5th. And you guys do that one on your paper, and then we'll do that one in just a second together. Okay, when you're done, you can look at this way on that first one. Okay, looks like everyone's done. And put the brakes on for just a second on this one because there's something that I wanted to point out on this one over here. 3 to the 6th, that's one that I think most of us should have memorized. And it is, in case you didn't know, it is 729. And don't forget that we have some ways that we can figure that out. So anytime there's a number that's raised to an exponent, we can solve that. And now if we have 2 to squared, and then we have x squared. Well, 2 squared, that's not in simplest terms, is it, Jenna?
No.
It's not. And we always want to get our answers. Always, always, always. We want to get our answers in lowest terms. We want to get them as simple as possible. So what is 2 squared, class?
4.
4. Okay, x squared. We can't really simplify that. So, because we don't know what x is. It could be 4, it could be 12, it could be a million something. So make sure that if we have a number being raised to a power, we get it as simple as possible. But if we have a letter, a variable, we can just leave it. Okay, let's go over here. This is the one you should have already had done on your paper. And I'm going to do this one, and let's see if you guys got the same answer I got. So I said, well, I checked to see what the operation we were doing was, and we're doing multiplication. So that works out in our favor, because now we know if we have the same bases, we can add. So we have x, and x. So looks good. Looks like we can just add those exponents straight across. So I should have gotten x, 3 plus 2 is 5, plus 5 is 10. By raise of hand, did everybody get that one? Looks like it. And x to the 10th power equals, Anna Grace? X to the 10th power. She's right. That's a trick question. We can't simplify that one anymore because we don't know what x is. Like I said, it could be desk, it could be anything. All right, we have another one down here. And the first thing we're going to look for every time is what operation are we doing? Are we adding? Are we multiplying? Jenna, make sure you're working on the work that we're doing for this class. So we need to make sure what operation are we doing. And we know we have parentheses. What operation does parentheses tell us we're doing, Jenna?
Multiplication.
Multiplication, that's right. So we've got one check mark. We've almost got the second check mark that tells us we're good to go. What is that other check mark that we need, Anna Grace, in order to add our exponents?
That they would have the same base.
The same base. And I see, Maya, you're kind of making a face like you're not, yeah, you're saying no, you're shaking your head that we can't add all of these because we don't have the same bases. We have a y, and a 2. So I'm going to write this one out just long form so we can see it since we have different terms in this one. So we have y times y times y. I think you all agree with that. We have y squared and our y. And then we have 2 squared, so we can make it smaller if we like, or expand it actually, and get 2 times 2. So we're going to just take what we have and put it together to get y cubed 4. But that looks kind of weird. We never say y cubed 4. How would we say that? How would we write this, Jenna?
You would put the 4 first.
Yeah, we would put the 4 first. It's just how we do things. 4 y cubed. So we can still multiply and we can still put everything together except if they don't have the same basis. So whenever we have a big, long problem, we want to separate and we want it to do it on our like basis. And we typically like to go in alphabetical order. So that brings me to this one over here. Look at this one with me. And we have multiplication, so that's one green light. And now we're looking for that next check. And we have an A up here. But we don't have an A over here, so we're just going to bring it down. It's all by itself. It doesn't have anyone to be like him. He is alone. There we have A. So, all right, Anna Grace, it is funny, but I don't think it's that funny. So we have x squared, and we have an x over over there, so we can just join our bases. So, we're gonna join our bases and add our exponents. So what should our exponent be, Anna Grace?
It should be cubed.
Cubed, or 3. And then our y should be what, Maya? Cubed also, so we should have y cubed. So you see how we just bring it down if it's not the same. So your book should be open, and you should be looking at our practice problems right there on page 122. I would like you guys to do 1 through 3 at your desk, and then I'll have a few of you come up to do them on the board in just a moment. Make sure you're working diligently at the desk, getting everything accomplished. Should be coming along nicely on your work here at your desk. If I can get Jenna to do number 1 at the board, Anna Grace to do number 2 at the board, and Kelly to do number 3 at the board. Make sure you are staying spaced out at the board. Once you're done, you can stay at the board because we're finishing up at our desk. Okay, Jenna, go ahead on number 1. Everybody look at the board. If you are done, hopefully you are and you should be, so look up here at the board. Number 1, Jenna has done this one for us. Jenna, tell us what you did and what answer did you get?
So first of all, I looked and made sure that we were doing multiplication, and we are. And I made sure that we had the same space, and we do. It is 6. So then I added the exponents. So I added 2 plus the understood 1 plus 3, and I got 6. 6 to the 6th power.
Everybody looks like they agree with that. Very good. Way to catch that understood 1. Remember, if it doesn't have an exponent above it, then we know that it is 1. Great job. You can erase that and have a seat. Anna Grace did number 2. That one looked pretty simple. I think she did it quite well. But go ahead and tell us what you did.
Well, we had division, and we had the same base. So I took the base and put it over here, and then I added 3 exponents and got 5 and 6.
Okay, and what was our operation?
I mean multiplication.
Multiplication. Because if we do have division, we're going to do things a little bit differently. But great job. We just added those exponents and went straight across. And then Kelly had number 3 up here at the board. Go ahead and tell us what you did.
Well, we are multiplying, so I made sure we had the same base, and we do. It's 11. So I added the exponent 1 plus 2 plus 4, which is 7. So I had 11 to the 7th power.
Okay, and please explain to us why, how did you know that we were multiplying?
Because they're in parentheses, a parentheses means we're multiplying.
That's right, very good. Just making sure that we know what our operators are. Very good, you can erase that and have a seat. So I have copied a few more on the board up here. You can do these along with me. And these are number 10 and 20 out of your book before we do some more practice problems. So let's go ahead and do number 10. Let's see here. So the first thing we want to do is check for multiplication. And are we multiplying, Anna Grace?
We are.
We are. We're using your favorite raised dots. So we are multiplying, and now we just have to see what we have that's alike and what's not alike. It's kind of like just sorting through and getting into our categories. So we have M's and we have N's. It's too bad that we don't have any M&M's, but we just have M's and N's. So let's look here, and we're going to go with our M's first, because we like to keep things alphabetical order. How many M's are we going to have, class? What is our exponent going to be on our M's?
3.
3, because this is what, class?
1.
Understood 1. When it doesn't have anything, we understand it to be to the first power. So we're going to go ahead and have M cubed, and then we have N squared, and then we have an N. So we're going to have, we know that this is understood, we already just talked about that for our N. So it's going to be M cubed, N cubed. So just something a little different when we have multiple operators and we also have multiple different letters that are kind of scattered. It's getting longer. So but we're doing the same thing every time, just narrowing it down one at a time. So let's look over here at this one. This one's kind of long. We have a lot of stuff going on here. So we have, what are we doing, Kelly? Are we dividing, adding, subtracting? What are we doing, Kelly?
Multiplying.
We are multiplying because we have our parentheses. And we also know that this is multiplication because they're two letters that are put together. So we're multiplying, so we know if we have like bases, we can just add them straight across. So let's go ahead, and what is the first one that you want to look at and try to get sorted out and pulled out, Anna Grace? A. We'll go with the first letter of the alphabet, making sure we're keeping it in order. So I'm going to go ahead and bring my A down here. And everywhere I don't have a number, I don't have an exponent, I want to just write that understood one so we don't lose it when we start adding. So I'm going to put my 1 here and my 1 here. So now we're just going 1 plus 2 class, 1 plus 2 class,
3.
plus 1 equals
4.
4. And then we are done with those. You can just kind of see them as gone, erase them, and we just have our X's. So we're going to do this again, class. I forgot to put this 1 right here. Let's see, class, if you guys can count a little bit better on our X's. So we have 2 plus 3
5,
plus 1 class,
6.
6. X to the 6th power. You guys look like y'all were separating these pretty well, finding our common bases and adding the